Whole cassava roots enter the controlled receiving zone for identification, inspection. Staging separates inbound traffic and prepares each lot for controlled intake without crossing clean routes. Verification prevents data mismatch before the lot moves deeper into the process.
Documentation review begins before release, so the plant can confirm origin, harvest lot, and receiving conditions.
Matching paperwork to the physical lot is essential before any quality decision is made.
Quarantine prevents unapproved raw material from entering the wash line before testing is complete.
Visual inspection screens for rot, severe soil load, and mechanical damage before representative sampling. Representative sample captures lot variability instead of judging quality from the top layer alone. Solids help characterize the incoming raw material and support later standardization targets. Recorded readings create the first data point used to judge process suitability and expected yield. pH contributes to process control decisions and helps confirm the lot fits the intended puree line.
Receiving decision can be traced later.
Receiving temperature indicates storage conditions and influences deterioration risk before processing.
And option by the Zesses. The audio is characterized by the sounds of an industrial environment, featuring the clatter of machinery.
Receiving data are reviewed together, so release is based on the full condition of the lot, not a single metric.
Once released, the lot can enter the line in sequence while preserving FIFO and traceability. The approved lot enters the wet receiving zone.
Controlled discharge protects equipment and reduces product damage at the first transfer into processing. Boom begins soil loosening while conveying roots forward without harsh drops that could increase breakage.
Short accuracy.
Spray rinse loosened soil.
Air agitation improves cleaning on irregular root surfaces without introducing hard mechanical impact. Sanitizer concentration must stay within specification to reduce surface contamination without damaging the product.
Verification confirms the wash chemistry is effective and documented rather than assumed.
The roots must remain in the treated wash long enough to meet the validated hygiene target. The final rinse removes loosened residues and prepares the roots for dewatering and inspection. Dewatering reduces carryover water, so downstream sorting can see true surface condition more clearly.
A quick visual recheck confirms the wash stage is performing before the roots enter dry inspection equipment.
Controlled transfer protects the roots and keeps the post-wash path separate from raw receiving traffic.
Manual inspection removes obvious damage that would lower yield and burden later trimming. Inspection improves consistency by flagging color and surface defects the eye may miss at line speed.
Automated rejection removes suspect pieces without stopping flow on the accepted line.
The trim station separates usable root tissue from peel and defects before comminution. Is shown on camera, so the main product and byproduct roots remain physically distinct and traceable. Peel enters the byproduct root for moisture reduction before drying and milling into fiber powder.
A light rinse clears peel fragments, so only clean root tissue proceeds to size reduction. Secondary inspection catches residual peel that could affect color and texture in the finished puree.
Rework preserves yield by correcting minor defects without compromising the accepted flow.
Size reduction creates uniform feed for grinding and stabilizes the load on downstream extraction equipment.
Controlled hopper feeding keeps the grinder loaded evenly and prevents surges that could damage texture.
Grinding ruptures the tissue and prepares the root material for pulping and subsequent screening.
Enclosed transfer reduces exposure while moving the mash into the extraction stage. Pulp extraction increases usable yield, while the fibrous fraction is captured for the locked fiber byproduct route.
Dewatering the fibrous residue lowers dryer load and makes the byproduct route more energy efficient.
The extracted pulp now moves to finishing, where remaining coarse particles will be removed before deaeration and heat treatment.
A short buffer stabilizes flow to the finisher and helps prevent uneven screening performance.
Controlled pumping maintains a steady feed so the finisher can remove coarse particles consistently.
Fine screening improves texture by removing residual coarse fragments before the puree is standardized.
Coverable coarse solids are combined with the fibrous byproduct stream instead of entering the finished puree. The inline sieve provides a final particle control step before the puree enters closed tanks. In-process sampling checks texture and chemistry before the pulp moves deeper into closed equipment.
To ensure quality, we check the pulp viscosity of the in-process cassava. The bench
Recording in-process data links texture control to the same lot that entered receiving.
Deaeration removes entrained air that could affect oxidation, filling stability, and heat transfer.
Removing trapped air improves product stability and helps the downstream heater work more predictably. A balance tank evens out flow between deaeration and the next closed processing stage. The dryer feed belt meters the byproduct cave evenly to support stable moisture reduction. Controlled drying lowers moisture to a stable level, suitable for later milling into fiber powder. Drying stabilizes the fiber stream and prepares it for controlled particle size reduction. Milling converts the dried fiber into a uniform powder suitable for bagging and secondary use.
Powdering and sifting improve consistency, so the byproduct can be packed as a stable fiber ingredient.
Particle size control improves handling and creates a more uniform byproduct specification. Wastewater treatment begins by removing suspended solids, and none of this stream returns to food production. Dissolved air flotation removes fine suspended matter before biological treatment. Concentrated sludge is removed from the treatment line and handled as waste, not as recoverable product. Biological treatment reduces dissolved organic load before final discharge handling.
Cleaning in place verifies that tanks and heat treatment lines are clean before sterile production continues.
conductivity and release checks confirm the cleaning sequence is complete before product enters the circuit again.
The blend tank provides the controlled point where the puree can be standardized to specification before heat treatment. Gentle mixing evens composition in the tank, so later specification checks represent the whole batch.
Record blend solids result.
specification is corrected here by blending with a higher solids cassava stream, which is a legal adjustment method for this product.
Post-addition mixing ensures the solids correction is distributed uniformly before the product enters the heater.
Verification prevents an off-spec batch from moving into sterile packaging conditions later in the process.
The verified blend now moves into the heat treatment system, where time and temperature become the critical control point. Outlet temperature must reach the validated target before product can proceed as pasteurized puree. Controlled cooling protects product quality and prepares the puree for aseptic surge and filling. Transfer temperature is confirmed, so the product enters the aseptic section under the intended operating conditions. Reviewing the CCP record ties the heat treatment evidence directly to the lot before aseptic filling begins.
A post-heat sample supports microbiological verification of the controlled process without interrupting flow.
Correct labeling ensures any later microbiological result can be traced back to the exact production lot and processing line.
Stable buffer conditions help the filler run continuously without compromising the sterile boundary.
The plant uses aseptic drums for this main product, so empty sterile containers are positioned before filling begins. The puree is transferred under aseptic conditions into the sterile-lined drum to preserve safety and shelf stability. Coating links the finished drum directly back to the receiving lot and recorded process controls. Check weighing confirms the target fill was achieved and helps detect underfill or overfill before release. Vision inspection confirms seal presence and code readability before the drum can be palletized.
Foreign body screening is placed here on the closed packaged product, where it is practical and hygienically appropriate.
Approved drums are stacked in a controlled pattern to protect package integrity during storage and transport.
Stretch wrapping stabilizes the load and protects labeled drums during warehouse handling.
Warehouse staging preserves traceability and FIFO control until the shipment is called to the loading dock.
Here are the shipping documents. Everything is loaded.
Okay, let me sign those for you.